Hey there, everyone. I just want to add a quick note to the solution that's posted for question number 11 from lesson 4. Um, so if you're looking at methods we looked at for working with vectors in that lesson, there's the scale diagrams, which is the basic level, the most fundamental skill, draw the vectors, measure them. The hardest part is establishing a scale, which is not hard. Components is very systematic. Probably the method of choice in grade 11. I know when I teach the course, I tend to steer students towards that because I don't want the math skills, any math skills that are missing, to be a stumbling point. So I figure this is the most doable version, simplest, kind of just straightforward to grind it out. Trigonometry, though, I showed here in that lesson that it certainly can be used as well. Just involves some higher end skills that you'd have to go and review, right? So, is it the case where you can always just default to using components because it's more straightforward? You can just grind your way through it. Well, the question number 11 kind of shows the importance of having all of the skill sets. Question number 11, you are given the net force, but you're missing the tension in chord 2, which means you're missing the length and the angle. So, like I said here, make sure to try it. It's a little trickier. And so in the solution that's posted for it, I just want to draw your attention to the fact that the being able to do the sine and cosine law work makes it not actually that hard. You can just put the 27 that's known and the unknown angle. We don't know the angle or the size there. But we do know it ends up being at 16 degrees 56. So you can piece that triangle together, in which case your cosine law and sine law isn't really any harder than normal. It's just different unknowns. If you were trying to do this with components, it would be a little weird because you'd be missing components along the way, right? So if you're looking at your X and Y components and you're thinking, okay, well, I've got, I guess it would be the 27 and the 0. And then you'd be saying here, like, okay, well, I've got whatever F2 is. And then you'd have, I guess, the cos theta. I'm just doing this on the fly here. And the F2 sine theta. And you'd know what they add up to, right? So you'd be able to get values here. And so I think it would be doable, but just looking at this and glancing at this, what I'm thinking is that you'd have an X and a Y equation. You'd have an X equation with an F and an angle that are unknown, and you'd have a Y equation with an F and an angle that are unknown. And so I'm just instinct-wise here, I'm thinking this would be two equations, two unknowns, which, is doable as well. But I feel like the sine law, cosine law is just a little bit more straightforward and a little less weird. But yeah, that, be interested to see if anybody wants to, carry that out and show me that it works. But it's be good practice for all skills and so on. I just want to touch base and make sure you recognize that the avoidance of all math skills eventually, is probably something you don't want to do. The sine law, cosine law stuff, yeah, for sure. You have to go back and review it, I'm sure, right? But see the power of it here. Whereas this, I think, I pieced that together because I'm experienced with this, but I think you might have felt that this is a bit of a dead end because you don't know things. Well, the trick to get through that is to state it in terms of the things you don't know. These are your known unknowns, or whatever you want to call it, right? Make the things you want based on the things that you want to find out. And so we know they have to add up the x, y's, and y, y's, and so on. So that would work. So I'll just leave it at that. Just want to make sure you recognize sine law, cosine law. Probably shouldn't keep avoiding those. Go back, review them, get to know how to use them. All right, that's all for now.